In this example, we want to simplify these expressions, and we're going to have to do a little bit of algebraic manipulation. We might have to use, or we're definitely going to have to use some of those Pythagorean identities that we just learned. So you know what I'm going to do? I'm actually just going to write the basic Pythagorean identity up on top. Sine squared of theta plus cosine squared of theta equals 1. Okay, so let's simplify this expression right here. I've got 2 minus the cosine squared of theta. Now they're not like terms, so I can't combine them as it stands right now. But why don't I do this? Why don't I take cosine squared of theta and replace it with something? So 2 minus cosine squared of theta. If I were to solve this for cosine squared of theta, I would subtract sine squared of theta from both sides. So that's going to be the same thing as 1 minus sine squared of theta. If I then distribute that negative, this is going to be 2 minus 1 plus sine squared of theta. And 2 minus 1 is 1, so this is actually equal to 1 plus the sine squared of theta. So a little bit simpler. I would make the argument that this isn't necessarily any simpler than my original, but I have been able to rewrite this a different way. So, take it as you want. This next one, though, certainly can be simplified a little bit further. I've got sine squared theta times cosine of theta plus cosine cubed of theta. Lots going on here. As it stands right now, I don't think that I want to just start popping in Pythagorean identities. Yes, I can make a replacement here, but I think that would make things more complex. And when I'm simplifying, I want to make things less complex. I want to group things together. I want to factor things if possible. And if I look carefully, I can actually see that I can factor out a cosine of theta. That exists in both this term here and in this term. So let me factor out a cosine of theta. And if I were to factor that out, I'm left with a sine squared theta plus cosine squared of theta on the inside. And you can confirm that by just thinking, well, if I distribute this cosine of theta, do I get this? Yes, I do. And I know that sine squared of theta plus cosine squared of theta equals 1. So this is the same thing as cosine of theta times, let me just switch colors to make this substitution. This equals 1. So it turns out that this whole expression that started off kind of complex is really just equal to the cosine of theta. So really all I need to do is I need to be able to manipulate things, factor things, and use those Pythagorean identities. It won't always be Pythagorean identity number 1. Maybe I'll be using the second version or the third version, but the process is still the same. So why don't you try this example here? A little bit tricky, but I think that you can handle this. So give this one, pause the video, give this one a shot, and see how it goes. All right, and here is my work for this one. You'll see the Pythagorean identity substitution I'll highlight here. This B really was a lot like the first one. A was a little bit trickier, so maybe you had a little bit of struggle with that, but hopefully you were able to make those substitutions okay.